Okay, you should have written down your solution notes. Now just reiterating, an unsaturated solution is a solution that can dissolve more solute, so it's not saturated. A saturated solution can't dissolve any more solute. A supersaturated has too much dissolved. Now, this is for a set amount of water. So let's say there's like 100 milliliters of water. If it's saturated at 100 milliliters of water, you can't dissolve any more solute. But let's say I increase the water amount to 200 milliliters. Would the solution still be saturated? No, it would be unsaturated because there's more water there. So saturation depends on how much solute you have and how much water there is. It also depends on the temperature, because as you've written down and gone over, for most things, if you increase the temp, you can dissolve more solute. Just like I'm sure you've made, or your mom has made, iced tea. If you want to make tea, sweet tea, you should make your tea and you make it hot, and then you can put all the sugar in it and then cool it down. If you try to dissolve sugar into cold tea, it's not really going to dissolve well because it's cold. But if you have hot tea, you put the sugar in, dissolve it, and cool it, it will dissolve easier. So increasing temperature helps you dissolve more solute. So does increasing the volume of water. So we're going to look at solubility curves. Solubility curves are graphs that show the max amount of solute that can be dissolved, and they're typically in 100 grams of water. So this graph shows me how much solute I can have dissolved for all of these chemicals in 100 grams of water. And so just how to read this. Let's look at the sodium nitrate, which is this one right here, this line. What this graph tells me is, let's just pick a temperature, so 10 degrees. At 10 degrees, sodium nitrate is right here. And so that tells me at 10 degrees Celsius, I can have, what is that at? 80 grams of sodium nitrate dissolved in 100 grams of water. And that's how you read this graph. If it was 40 degrees, and this is the same graph that's in your notes, 40 degrees, sodium nitrate's like right here. And so that is a little less than 105. I don't know, let's say and you don't have to read these exact, that's like 103. So I can have 103 grams of sodium nitrate dissolved in 100 grams of water at 40 degrees. And so you can see sodium nitrate increases the solubility. So as the temperature goes up, you can dissolve more solute. That is the case for most things. Sodium nitrate, potassium iodide. Potassium iodide, look, it goes off the chart past like 25 degrees. We've got potassium nitrate, ammonia chloride, etc. The cesium sulfate is kind of weird. It actually decreases, and so does the NH3. But this is what this shows us. And so you can tell this graph if I look at a point. So let's say, what was that? That was 20 degrees. Okay, on the zoomed in graph, 20 degrees of NaO3 is like, it's a little less than 90. That's like, I can have 88 grams of NaNO3 in 100 grams of water. So let's say you read a problem, and I know that because that's where the line is, and the problem said, I have 70 grams of NaNO3 in 100 grams of water. Is my solution, and that's at 20 degrees, is my solution saturated, unsaturated, or supersaturated? How you would figure that out is, okay, well at 20 degrees you can have about 88 grams of sodium nitrate dissolved. If you only have 70 grams dissolved, you can dissolve more, so that would be a unsaturated solution. So these graphs can help you figure out if solutions are saturated or unsaturated. Okay, here's the next problem in your example. So at 45 degrees, 60 grams of potassium nitrate are dissolved in 100 grams of water. What's my solution? Saturated, unsaturated, supersaturated. So my potassium nitrate line is this red. At 45 degrees, it is like right here, which that is, I probably didn't draw it perfectly straight. You can have about 74 grams dissolved, about 75, but I have 60 grams dissolved. So could I dissolve more? Yes, I can. That's an unsaturated solution because you can dissolve at 45 degrees about 73 and you only have 60 grams dissolved. Next one. At 60 degrees, 70 grams of NH4Cl, ammonium chloride, are dissolved in 100 grams of water. So what's my solution? Okay, 60 degrees, ammonia chloride can have about 55 grams dissolved. But this says you have 70 grams dissolved. I should only be able to have 55 grams dissolved based off of that graph. And so when you have more solute dissolved than you should, that was called what again? Supersaturated. So I got more solute dissolved than I should. That's a supersaturated solution. And so when you're looking at heating curves, and you have, or not solubility curve, sorry, and you have a problem. If the number on the problem is the same amount of solute as what's on the line, so let's say for potassium nitrate, this right here is 80 grams at 50 degrees Celsius. So if I read a problem and it was right on my line, it said I have 80 grams at 50 degrees Celsius dissolved in 100 grams of water. That would be a saturated solution. If it's below the line, so let's say the problem said KNO3 at 50 degrees Celsius, I have 60 grams dissolved. That would be below my line. That would be down here. That would be an unsaturated solution. And if it said, for this example, I have 100 grams dissolved, it's above my line, that would be a supersaturated solution. So this line tells you what a saturated solution will have at that temperature for that substance in 100 grams of water. But what if you don't have 100 grams of water? What if I had 200 grams of water, like this problem shows? So how much NH3 can be dissolved in 200 grams of water at 10 degrees Celsius? Well, let's look at our graph. Our graph is for 100 grams of water. So at 10, you can have, right at 10 degrees, I can have 70 grams dissolved in 100 grams of water. Well, if I double the water, and now there's 200 grams of water, I can have twice as much solute dissolved in it. So what is 70 times 2? I could have 140 grams dissolved in 200 grams of water. So these relationships are proportional to the amount of water. If you increase the water, you can dissolve more stuff. What if the water tripled? So this last example, if you have 300 grams of water instead of 100, this wants to know about KNO3 at 50 degrees Celsius. Okay, so at 50 I can have 80 grams of KNO3 dissolved in 100 grams of water. Well, if I change it to be 300 grams of water, that is 3 times as much water. So I would take my solute and multiply it by 3. And so what's 80 times 3? 240. 8 times 3. So you could have 240 grams of potassium nitrate dissolved. And then, oops, sorry, you can't see that. and then I could even change the question, and maybe I said at 50 degrees Celsius you have 200 grams of KNO3 dissolved in 300 grams of water. What's the solution? Well, there we go, so you can see that. Looking at my problem, okay, a saturated solution was 240. If I have 200 grams dissolved, I could dissolve more, so that would be unsaturated. So you can take these graphs and still, even if the water amount changes, still answer saturated, unsaturated, etc. So pay attention to your water amounts. This is the solubility curve you're going to be using for just about everything. That's why it's in your notes and in color. And you'll see this one a lot. This is the one you'll see on your test, so you can get very familiar with it.